Hello, my name is Mike Parks, and on behalf of Mauser Electronics, I'd like to talk to you about a stepper motor project we built that's going to be driven by an ST Nucleo and controlled remotely over Bluetooth with an app we wrote on Android. So let's first talk about what the BuddyBot does. Well, like I said, there's a companion app that's written in Android, and we'll provide this in the Play Store if you want to just go ahead and download it. All we do is we connect to our Bluetooth module that's connected to our Nucleo, and once we've done that, we've got just a couple simple commands. We can turn the laser on, and we can turn the laser off, and hopefully you can probably see that right about here. So we turn the laser on, and then we can move the motors left and right. And you notice we had a little interrupt there with the stepper motor. We have kill switches to make sure we don't go too far left and right. And then we can actually set it into a robot mode. So if we're ourselves or maybe a little lazy and we don't want to sit around all day and play with our cat or dog, we can enter a robot mode, and we use the ping ultrasonic sensor here to detect when the cat or dog's in the way, and when it is, it will go ahead and at a set interval move the laser for us. That way we can get a little rest and our pet can get a little exercise. Alright, let's take a real quick look at the hardware. We have the Nucleo here with all the signal wires and the power and ground coming off of it. We have then the 5-volt voltage regulator that we're going to power off the Nucleo 5-volt pin. We're going to run that through a 10K ohm resistor for the H bridge, the L293D. That's going to be a little current limiting resistor that goes to the enable pins of the chip on pins 1 and 9. Then we're going to take the 5 volts out the regulator and also put that for power to pins 8 and 16. That'll also pass the power for the motor itself. For the stepper motor, notice that we're combining, again, the wires. So wire 1 is the orange and the black and white striped wire. Wire 2 is the black and the orange and white striped wire. Pin 3 is a red wire and the yellow and white wire. And pin 4 is the yellow wire and the red and white striped wire. And you notice that we take those out, we give them pin names, labels that match over here on the L293D. So it should make wiring up pretty straightforward. Down here we have the voltage divider, we have the pull down resistor for our limit switches that will make sure that the stepper motor doesn't go too far left and too far right. So there's the switches themselves. Again, a little pull down resistor for so that there's no floating gates, no floating inputs. Then we have our little screw terminal blocks for our ping sensor to connect. Again, we'll have the ping sensor up on the little rotating head. We'll take a cable in, connect it to here, and then it'll take that and feed it. Again, these wires will correspond over here on the Nucleo. Same thing for the laser. And then also the same thing for the RN42 Bluetooth module. You'll notice that the signal names can be matched up to the Nucleo. One last thing to point out, we have our little voltage divider here because, again, the Nucleo is a 5-volt device, but our little RN42 is a 3-volt device. So when we are transmitting from the Nucleo to the Bluetooth, we're going to take the 5 volts, drop it down to 3 volts with the divider. That's our 5 kilo ohm resistor here, and the 10 kilo ohm resistor right here. And that will do it. Okay, so when you're ready to get started with the software, you're going to head over to developer.mbed.org to create a free account that will give you access to their compiler. You click on that and you're launched into your workspace where all your programs that you're working on are tracked. We're going to go ahead and launch the BuddyBot. And I'm just going to do a quick couple highlights on some of the key things of the software and some of the tool itself. The first thing is the import function. So I used an existing library for the ping ultrasonic sensor. And to do that, you just click on the import button and you can type in whatever you're looking for. So like here's the ping for the parallax ultrasonic sensor. You click on that, you import it, it's done. It goes right into your library. Alright, let's move over to the Android app. So the Android app is created using the MIT App Inventor. So we'll go ahead and launch our BuddyBot app. And again, this is nothing fancy, nothing too amazing. Pretty straightforward. We have checkboxes for the laser and the robot mode. So if there's a check, we have the laser on. If it's unchecked, the laser's off. We added 2 buttons, one for a left and one for a right, and then we gave it a instead of using the words left and right, we just uploaded a little image file that I drew up of a left arrow and a right arrow, and we're using that to control the motor left and right. And then we have 2 other buttons down here to pair to a new Bluetooth device and then connect to our Bluetooth device. Alright, now of course the last thing we have to do is actually test it with a real world subject. So we use our cat here, London. And the first thing we'll go ahead and do is we'll go launch the BuddyBot app. Go ahead and connect it. There's our Bluetooth module. Alright, you notice now it says disconnect. And we'll go ahead and turn the laser on. And let's adjust that down a little bit. Actually, I'll scoot this back a little bit. There we go. Uh-oh. What did you do to it? Now, go ahead and... Uh-oh. Where'd he go? Alright, so that's the BuddyBot. Now it's your turn. We're going to include links to all the source code, both for the Nucleo as well as the Android app. We're going to put the link to the Android app in the Play Store. We are going to include all the schematics that we've used, and we're going to throw up the STL and SketchUp files that we use to do 3D printing of the parts to hold this all together. They're not a requirement, but they're there if you want to use them. So with that, on behalf of Mauser Electronics, I'm Mike Parks. Thank you very much for watching.